Turn on vacuum. Make sure that the valve of the vacuum manifold is closed. Slightly open the valve to pull contents off the wells. Note that the optimum vacuum will pull the wells to dryness in 2 to 5 seconds. The vacuum pressure should only be between 4 to 7 inches mercury or Hg to avoid damage of the membrane filters. With vacuum still running, quickly rinse each well twice with 200 microliters ice-cold assay buffer using multi-channel pipette. Gently close the valve of the manifold and turn off the vacuum pump. Remove the plate from the manifold. Remove the plastic bottom from the plate. Place microplate in a counting cassette. Seal the bottom of the 96 well plate with sealing tape. Add 50 microliters scintillation cocktail per well using multi-channel pipette. Seal top of plate with sealing tape. Allow to sit a minimum of 1 hour at room temperature. Count using a microplate scintillation counter. Step 3. Analysis using graph pad prism. For the analysis of results, any statistical software with Receptor assay applications will suffice. For this learning module, we will use the graph pad prism. Have the counts or readings from the liquid scintillation counter ready and turn on graph pad prism 6. Any version of graph pad will work the same. The Welcome to Graph Pad Prism dialog box opens. For receptor binding assay for saxitoxin, choose XY from the choices on the left of the dialog box. Tick number of replicate values in side-by-side subcolumns. Click Create. A new project labeled as Data 1, default but can be changed. X column is labeled Concentration in nanomolar. Y column is labeled CPM. Label X-axis with the concentrations used in assay. 1000, 100, 30, 10, 3, 1, 0.1, and your reference. Fill all necessary data using the data generated from the liquid scintillation counter. Click Analyze. The Analyze Data dialog box opens. Click Transform under the built-in analysis, then Transform. Tick the datasets to be analyzed on the right. Click OK. Parameters Transform dialog box opens. Select Standard Function. Select Transform X values using X is equal to the log of X. Tick Create New Graph of Results below, then OK. X-axis values are now converted to its log form, which found under the Results folder on the left side. A new graph is also created. 13. Selecting the transformed data, click Analyze. 14. Select Nonlinear Regression Curve Fit from the XY analysis options of the Analyze Data dialog box. Choose the dataset or sets to be analyzed on the right and click OK. Parameters Nonlinear Regression dialog box is opened. Select Sigmoidal Dose Response Variable Slope under the classic equations from prior versions of PRISM. Also select Interpolate Unknowns from Standard Curve and Least Squares, Ordinary Fit. The default confidence level is set at 95%. The program will give data names tables of results, which includes EC50, hill slope, and correlation coefficient, and interpolated x-means values. Select the interpolated x-mean values, then click Analyze. Analyze Data dialog box will be opened. Select Transform, then OK. Parameters Transform dialog box will be opened. Select under the standard functions the option Transform Y values using x is equal to 10 to the x power, which is to revert the values from the log form. Click OK. Values produced are the concentration of saxitoxin from samples in nanomolar STX equivalents, or NM-STX equiv. Compute for the value of saxitoxin in UG level per weight of shellfish meat in kilograms. Also report the table of results under the nonlinear regression or curve fit. It will give the values for EC50, hill slope, and correlation coefficient. RBA criteria. During analysis of the data, there are several criteria that must be satisfied to accept your assay result. These are: 1. For a ligand that interacts specifically at one receptor site, the slope of the resulting standard curve should theoretically be 1.0. If the slope of the curve for a given assay is outside of the acceptable range of 0.8 to 1.2, linearity of the assay will be compromised, and quantification of the unknowns will be incorrect. Therefore, the assay should be rerun. 2. RSDs of the CPMs for standards must be below 30%, as variability will affect quantification of the samples. 3. The RSD of the QC check should be less than or equal to 30% of the stated value, or 3.0 nanomolar. As for the acceptability of a sample measurement, the following criteria must be met. 1. Sample quantification should be done only on dilutions that fall on the linear part of the competition curve. B over B sub 0 equals 0.2 to 0.7, where B is the bound CPM in the sample and B sub 0 is the max CPM. 2. In the event that no sample dilutions fall within the linear range, that is if the concentration is too high, resulting in B over B sub 0 less than 0.2, further dilutions must be made and the sample should be reanalyzed. In the event that the sample concentration is too low to be quantified, the B over B sub 0 is greater than 0.7. The sample is reported as below limit of detection. 3. The RSD of the sample CPMs must be less than or equal to 30%.